Hey everyone, hey, how's it going? So thanks for the introduction there. I am, of course, Nigel Hanlon, Nearformer. Proud of it anyway. I've only been with them for a month, but anyway, got talked into doing this, but sure, what can you do? Right, so tonight I'm hopefully going to be giving you a brief introduction to GraphQL. I say brief introduction because I've only been using it for about a month myself. So this is kind of, I suppose, setting a challenge that, well, could you give a talk about it? So learn enough to give a talk about it. I don't know, if you want to look at it that way, maybe not, but... so in tonight's talk, I'm going to be defining REST, its strengths and weaknesses. REST is something we're all obviously probably very familiar with. An introduction to GraphQL, what is it? Defining the schemas and types the GraphQL uses. Working with resolvers, which glues everything together. Some server-side tools, so Apollo and friends. We'll also be looking at Fastify. There's just a brief kind of mention of some client-side GraphQL stuff and some questions and answers at the end. All right? So, defining REST. I think anyone who's ever developed anything web-wise or used a REST API kind of has a notion of what REST is, you know, your gets, your posts. So, REST actually stands for Representational State Transfer. So there's kind of two key words there, representation and state. So it's kind of the management of state on a server and the transfer of that from server to client, as well as the management of it through time. REST isn't a protocol exactly, it's more of an architecture. So it describes how clients and servers should exchange information. It was proposed by Roy Fielding as part of his doctoral dissertation in 2000. So if you think about it, 2000 doesn't sound that too long ago, but I mean, we're talking 17 years, so REST has been around for quite a long time. I wouldn't say REST APIs have, but you know, sort of the idea and the standards as it evolved. So in his proposal, he put forward these 6 constraints of REST. Now some of these, like, when you look through them, it sounds a bit strange, but when you actually read into it, they do make sense and they're kind of more intuitive than you think. So the first one, uniform interface. That's resources are manipulated by defined methods. So that's our verbs like our get, our post, resource is available at a certain URL / this ID, that kind of idea. So sort of like that's an agreed way that we're going to talk between server and client. So that's what we mean by a uniform interface. Stateless, so things on the server will stay the way they are until something interacts with them or the state changes. Generally, like you know, if it's a client changing something, so they might post something to create something new, or you know, they might delete something, that sort of idea. If things are stateless, that means they're cacheable. So we're not expecting them to change unless we change them. So some things on the web can be cached. So that's that idea there. The idea of client and server, and both of them are interchangeable or completely changeable. So long as we all talk the same uniform interface, it really doesn't matter client and server, whether it's a smartphone, a server, an IoT device. It really doesn't matter what's on either side of the conversation, as long as it's the same. The idea of a layered system, so it doesn't matter if you're behind 7 proxies. The conversation of, you know, get and post and the resources are going to look the same. They should look transparent. The last one, now this was written in 2000, so you know, Java applets still roam the earth. We're still plagued by Flash and the rest of it. So this is the only optional one he put forward, where a server may extend the client functionality with additional logic. So a server could have a client download an applet, for example. So REST really doesn't define a transport. You can use REST over a binary interface, RPC, but one of the most common ones is over HTTP, which would be one of the ones that we're most familiar with. So for example, we have just in the columns here, we have the verbs, how they relate to CRUD, so your create, read, update, delete kind of process, and a rough description. So I think everyone's kind of familiar with the first two, post and get. So post generally creates something, or in terms of a login, so we're creating a new resource. Get, so whenever you go to a new web page, or whenever you want something from an API, a get request, so read, like get one or more resources. Push, so update a resource that already exists. Patch, it's included in there for completeness, but I don't know if many people use it. It's sort of like update by difference. So imagine like if there was a blog post and you'd just be sending the differences between this version and the one that's on the server. It's kind of dangerous enough to use. It's like the go-to of kind of HTTP verbs. And then we have delete. So that one should be fairly self-explanatory. So just to give an example, if we had an imaginary blog, so we might post to an endpoint that says create post. If you want to get a certain post by ID, so we have, you know, our verb get, we're looking for a post resource with this particular ID. Same with push, it follows the same kind of syntax here, as well as patch and delete. So the core kind of idea is, that's a method, this is a resource, and you have the identifier identifying which particular resource it is. So that's fairly standard. I think we're all kind of familiar with REST from that point of view. So a couple of reasons why REST is awesome. You have freedom of implementation. So REST kind of says, well, this is kind of the way it is, and you're free to make your API whatever way you wish. It's transport and language agnostic. So HTTP is the most common, but you know, if you're doing it over WebSockets, if you want to do it over some binary protocol, that's fine. You're free to do that. Just REST is an idea, it's an architecture. So that's up to you. The idea that once we learn how to do this, we can use it anywhere. I mean, once you learn how to get and post from one API, you can pretty much do that to any other API. And pretty much everything seems to have a RESTful API of some sort. I mean, we saw earlier on there in the previous talk from Ramon, we were talking to the GraphQL server on Facebook, so graph.facebook. So pretty much everything these days seems to have an API. So, reasons REST sucks is kind of the very first reason again. No one can really agree what a REST API should look like. So, I designed an API one way, you might have a different idea. You know, it's an evolving kind of standard and no one's quite sure what it should look like, but everyone's convinced the other guy's doing it wrong. So modern app state is a bit more complicated than what REST kind of describes. I mean, back then you were still using forms, you're posting them, you know, we didn't have React, we didn't have Angular back then, so the states and the resources that REST represents are a little bit behind the times compared to our modern apps. Depending on how complicated your API is, you're going to need multiple endpoints for different resources. So if you don't architect that right from the start, you're going to end up with a tangled mess. And as I mentioned before, people kind of confuse REST and HTTP. They're not the same thing. REST is the architecture. HTTP is kind of the how we get there. It's just a transport. So bearing in mind what REST is, we're going to have a look at GraphQL and what problems that GraphQL solves. So GraphQL is a query language for APIs. So what that means is you can take the data that you have, and instead of trying to split it into, oh, posts are on this API endpoint, you know, something else is on another one. We do away with all that. We have one endpoint, we write a query, we send it to the endpoint, and we get back exactly the data that we want. Now, to do that, we of course have to define types and fields to make a GraphQL service. So I mean, it's not magic. It needs to know, well, this is my data, it's this big by this wide, and it's these types. You know, it has to actually know a description of your data before it can do this. So, as I said, there's no rigid endpoints. You query and receive exactly what you need. Just, I suppose, a bit of trivia of that. Anyone familiar with a graph kind of data structure? It's essentially what GraphQL is named after. The idea being that every kind of node on the graph would be resolved to a solid type, like an integer or a string or something tangible. So you don't really need to know that to use it, but just good to know, I suppose. So just to kind of explain it in that, in terms of a simple blog. So let's say we have 3 different kind of objects for our blog. So we have posts. So this is the actual content that people write. The idea of a user account. So these are like the people who are writing the blog posts. And then comments. So other users can comment on different blog posts. So just a fairly straightforward, very simple kind of blog. You might kind of arrange it like this. So, you know, my posts are on, you know, /posts, or if I'm on a particular post by ID. Same with users. Every user would have an ID, for example. So if I want a particular user, I can get it by ID. And of course, comments. Comments are all going to be related to a post. So, you know, give me the comments for a particular post ID. Straightforward, simple enough. The issues with it is, if I want to display a page with a blog post, I'm going to have to make a minimum of 3 calls. So I'm going to have to make a call for the post, I'm going to have to make a call for the author of the post, so I'm going to have to make a call to users. And if I want to know what comments are for this post, that's another call as well. So you might say, okay, well look, if you engineer it a different way, that's fine, but it should be easier than having to try and re-engineer it that way. So as I said, like if I want all posts by a given user, which endpoint should I change? Should I change the user one? Or should I change the posts one to say, well, search by this? You know, you're suddenly straight away into a lot of different architectural kind of, which way should I go? And that's, like I said, the planning from the start. Unless you kind of nail it down really well, it can kind of become a mess on you. And then going forward, well, if I want to change the APIs, am I going to break them? You know, if I want to add functionality, do I create a new set of them with a version number? You know, it shouldn't have to be this way. So that's kind of, these frustrations are what GraphQL was kind of born out of. So, as I said before, if we want to use GraphQL, we're going to have to define our data in terms of a schema and types. So GraphQL gives us a syntax to actually do this, and it's very straightforward. It looks a bit like JSON, and you see it now in a minute. So there's certain types that come with GraphQL, so our Boolean types, our string types and such, but it also allows us to kind of extend that to our own custom types. So, for example, if I want to represent a post using the GraphQL kind of syntax here, so I'm saying my type is post. Now, it looks like JSON, but there's no commas here or quotes or the rest of it. So when I first started, I started quoting things and commas, and the amount of errors was ridiculous. But so everything has an ID. So this kind of special ID type here. The exclamation point just means it is required. So all posts have an ID, a title, the actual content of it. Tags here is an array of strings. So the exclamation here means that I can have one or none tags, but if there is a tag, it has to actually have some content. Whereas if I put the exclamation outside it, it means that I can't have a post without tags. So there's kind of subtleties like that that kind of catch you out, but you know, it's altogether it's pretty good. You can define other types. So author here is a user type. So I'll show you the user type now in a minute, but same with the comments. So comments is just an array of comments. Date, for some reason, which I don't quite understand, date wasn't actually included as a base type. I think it should have been, but it was their choice. And you know, whether a post is public or you know whether it's actually been published. So just to say the Boolean there. So there's our three objects using the GraphQL kind of type syntax. So you've seen the post. The user there, pretty straightforward. So it has an ID as well. Name has to be a string, name and email, and you can add in their Twitter account if they want to. Query. Actually, I have the wrong one there for comment, but you kind of get where it's going. This is the problem with doing slides on the morning of the talk. So if we define a type for all of the objects that are going to be used in our array, or sorry, in our API, that's great, but we need some way to map kind of our data to these types, and that's where resolvers come in. So GraphQL is pretty powerful in that it lets you source your data from anywhere. So your data can come from Mongo, MySQL, Postgres, Elasticsearch. It can actually come from another GraphQL server, a REST API, doesn't matter. So long as with the resolver, now resolver is just a function that defines how we map this data to these types. So I'll show you in a demo here now in a minute how that works. It'll actually be a little bit more clear, but bear with me for a second. So I've put together just a repo on GitHub which just implements a very basic kind of GraphQL server. I'll send around the link to it now afterwards and that. So let me see. Make this somewhat readable. Right, so So this is some of the data. I've hard-coded it. It can come from anywhere else, but I've just hard-coded this for now. So this is an array of posts. So as you saw before when I defined the types, I have ID, title, content, etc. So I have two posts there, a user account, and comments. So with these here, I can then define resolvers to match that data to the types. So if I show you the type definitions I have here. So as they were before, so I have a type post, type user, type comment, and these are the queries that I can run on these. So for posts, I can return an array of posts. If I want a particular post, I just take an ID and I'm going to return a type post. Same with user, I take an ID, and comments as well, I can return those here. So I'm defining, well, this is kind of the interface from the front, so this is what you can query. And to back that up are the resolvers. So the resolvers are pretty straightforward. They're just functions here. So I can say, if I want posts, it's literally just return the posts array. If I want a particular post by ID, so I just look through my posts, finding a post that happens to match this ID. Same with comments and the users here as well. So it's essentially just simple functions mapping to data, and that's all the resolvers do. They take whatever arbitrary data from whatever source and make sure that it matches the types. So, a second here. So what I have here, I have this server running. It's quite simple, it just runs on port 8000 and it gives you a simple interface here to play with GraphQL and the types that we defined. So if I say I want to run a query, so all the queries for GraphQL is just simple strings here. In this, it just happens to autocomplete. So I want all the posts. So I want title. You can pretty much evolve the query to be whatever data that you want. So if I just wanted these IDs, instead of having to query different things, I can just tell it explicitly, this is the data that I want. And it pops the JSON. So that's, how are we doing for time? You right?
Yeah, 10 minutes.
Grand. So I'll give you the link for this and you can play around with it, but that's the kind of general idea of GraphQL. So instead of going to many different REST points for different data, we can just explicitly say, I want posts and I want these details on these post objects. And from our mobile app or whatever we were consuming it with, get exactly the data that we want. So on the client side of that, I mean, that query there is just simple text. You can literally just post that to the GraphQL endpoint and get the JSON back. So you can build that query string yourself just using vanilla JavaScript if you want, or whatever your language of choice is. There's also a tool called Relay, which is developed by Facebook. So there's Apollo Client as well. These here, they're really doing the same things, just putting together this this query string, but they have a better understanding of the actual schema that's on the server side, so it kind of help you out in that kind of regard. And of course, Google and NPM, there are numerous packages there for working with GraphQL. It's really quite common. So, thank you very much.